Hello students, welcome back. We are studying this chapter, Introduction to Euclid's Geometry, and we have talked about the concept, the axioms and the postulate of Euclid's division lemma. In the previous session, I've told you that we are going to start doing questions based on the given axioms and postulates. Okay, so should we continue it now? Okay, so the very first example was if A, B and C are 3 points. 3 points are which? A, B and C. Okay, on a line, and B lies between A and C. That means it's having something like, we are having A, B and C, 3 points on a line, and B lies between A and C. So we are having 2 points, and these 2 points are point A and the point B, point C. Okay, and in between these 2 points there is a point B here. Okay, prove that AB plus BC equals to AC. What we have to prove? That this AB plus BC is equals to AC. Okay, so if we draw the figure here, this point A and C, and we are having something here B. So by observation only you can say that okay, this complete part is equals to this part plus this part. Okay, so first in the figure given above, AC coincides with AB plus BC. Now this is AC, and what is AC? It's coinciding AB plus BC. If you are having two parts, AB separate, BC separate, and you will going to overlap these two parts with this complete line, then it is coinciding the complete line. Okay, it will coincide the line completely, the complete line AC by the lines AB and BC, by the line segment AB and BC. What does that mean? This means that they are coinciding each other, and this means that if they are coinciding each other, they are equal to each other according to Euclid's axiom. Okay, so Euclid's axiom, the fourth one, says that things which coincide with one another are equal to one another. So due to this fourth axiom, we'll say that AB plus BC is equals to AC. Understood this thing? Okay, right. Next, example number 2. Prove that an equilateral triangle can be constructed on any given line segment. What we are going to do in that situation, we are going to draw a line here. We are going to draw a line here like this, and this line will have certainly 2 points A and B. Now what will we do? We'll draw a circle with the radius AB. If I'm going to do that, this will be an arc that will be drawn from point A as a center A and the radius AB. I'll draw the circle. So here's the arc. Similarly, from the point B with the radius same AB, I have to make an arc here also. Alright, so this is the center. Listen, this is the center, right? And this is the arc drawn by me on this. So this point, any point on the arc or on the circle, and when I'll join this to this point A, what will that become? That will become equals to AB. So if this point is C, then this AB is equals to AC. How? By the construction, we are taking the radius equals to AB, and this is also a radius. Similarly, when we talk about if this is the circle C1 and this is the circle C2, so if we talk about this other one, here this is B, here this is A point, okay, here this is B, and we have drawn the circle C1. So in the circle C1, if we take this point, from this point to this B, what is this? This is the radius of what? C2 circle, and C2 circle's radius is also what? AB. That means this AB is equals to this. Okay, so this is equals to AB. AB is surely equals to AB, and this side is also equals to AB. So here this is then 60 degree, 60 degree and 60 degree. Why? Because the sides are equal. So it's an equilateral triangle. Okay, that means if you're given with any segment, any line segment, then you can draw an equilateral triangle on that. It's clear to you guys? Okay, so here the two circles meet at a point. Say C. How we gonna do that? I've told you, from the point A with the radius AB, you are going to draw a circle. You can draw it completely. From the point B, taking radius as AB again, we are going to draw the circle C1. Okay, and when these two circles intersect each other, we are going to name it as C. At this point C, the distance from the point A is equals to distance from the point B, and these two distances are equals to AB. Why? Because they are somehow creating as a radius. Okay, so we have to prove that equilateral triangle. So here AB is equals to AC, again AB equals to BC, this is equals to this, and this equals to this. And here again Euclid taught us that if two things are equal to each other, if one thing is equal to another thing and also the another thing is equals to the one thing, then these three things will be equals to each other. That does mean that if A equals to B and B equals to C, then C equals to A or A equals to C. With the same concept, we can say that AB, BC and AC are three all equal. Okay, from these two facts, and Euclid's axiom that thing which are equal, the same thing are equal to one another. Okay, so by this we can conclude that AB equals to AC equals to BC. Alright, so triangle ABC here will be an equilateral triangle, and with the same procedure we can make it, right? With any given line segment we can make an equilateral triangle. Understood this thing, right? Okay. Now, theorem. Two distinct lines cannot have more than one point in common. Okay, two distinct lines cannot have more than one point in common. If you are having two distinct lines, this one is AB, right? And let's suppose this one is CD. So how many common points that will be having? Only one, this. Now how is it possible that only one common point is here? So in this case we are going to use the contradiction. Okay, so by contradiction, let's say that two distinct lines will have So in this particular case, we are going to use the contradiction method. Okay, on the contrary, we will be assuming that okay, it is actually having more than one point in common. Okay, so if we assume that, okay, let us assume in the contrary that two lines will have more than 1 point, or let's suppose 2 point. In common. Now, according to Euclid, is it possible? Euclid clearly stated that two lines cannot intersect each other more than one point. Okay, so on the construction we have assumed that, so by Euclid's axiom, it is contradicting, which is forcing us to assume that two distinct lines cannot have more than 1 point in common. Okay, so this is the way, this is the method of contradiction, when we assume something that okay, it's not, if it's not like this, it should be like this. Okay, and then the outcome will be what? Not as expected, or not as the not in the valid context. Then we realize that okay, we made this mistake due to we have the wrong assumption. So our assumption will be will have to be right there. So we will correct our assumption. In this case, we were assuming that two distinct lines can have 2 points in common, which was not possible. So we concluded that okay, it will have only 1 point in common. Okay, the next one is the exercise question. Okay, the first one we were talking about, while of the which of the following statement, this is which, right? This is which. Which of the following statement are true and which are false? Give reasons for your answer. Okay, so first one is only one line can pass through single point. This is single point. Okay, now only one line is passing through this point. This line is passing through this point. This line is passing through this point. This line is passing through this point. And I can draw infinite lines on this point. So this is basically false. Okay, and why it is false? We can use the axiom too, but at the same time we can just draw it and prove it wrong. First done. Then the second one, there are an infinite number of lines which pass through two distinct points. Okay, now let us assume the Euclid's axioms, when he clearly stated that 2 points will have only and only one distinct line. If we are having 2 points P and Q, you will be having only one line passing through these 2 points, right? Okay, from 1 point we can draw infinite many lines, but from 2 points we can draw only and only one line. Now the third one, the terminated line can be produced indefinitely on both the sides. Okay, a terminated line. What is a terminated line? If I am having this line PQ, then it is a terminating one. Okay, I have told you in the previous session that this line, we can extend this line like this, okay, and this line like this also. From the very both ends, we can make it infinite to this end also and this end also. That means this is completely false. Okay, a terminated line can be produced indefinitely. Okay, so this is actually what? True. This is true because it can happen. We can draw it here. Then the fourth one, if two circles are equal, then their radii are equal. Now, according to Euclid, if two figures are coinciding each other, they are overlapping each other completely, that does mean that these two figures are what? These are same or equal. So, if we talk about circle, if a circle overlaps another circle, that can happen only and only in one condition, that their radii will be the same, their radius will be the same. Okay, so here in this case, if two circles are equal, then their radii are equal. Is it so? Yes, it is. So due to the postulate, we can say that according to Euclid's postulate, we can say that it is true. Okay. Now the fifth, if in figure, if AB equals to PQ, this AB is equals to PQ, and this PQ is equals to XY. Okay, then what? AB will be equals to XY. Is that so? Okay, so according to Euclid, if A is equals to B, or should we change the ink? Okay, so according to Euclid, if A is equals to B, first thing, and the second thing, if B is equals to C, then he concluded that A is equals to C. In words, he have said that if two things are equal to the same thing, then the two things will also be equal or same. Okay, so with that we can say that, okay, if AB equals to PQ and PQ equals to XY, then yes, AB equals to XY. So we can again name Euclid for it. We can blame Euclid again for this, that yes, it is true. Understood? Alright. So see what's the next thing is, give definitions for each of the following term. Are there other terms that need to be defined first? What are they and how might you define them? So when we'll talk about parallel lines, perpendicular line, line segment, radius of a circle and square, we'll be talking about sides, we'll be talking about line, we'll be talking about point. Okay, these are the main words that need to be defined first in order to define these definitions. Now, first thing, we have understood these terms in our previous session, so we will not talk about the prerequisite things here, but we will be having a look on these lines. What are the parallel line, perpendicular line? You know all these kind of things. So the parallel line, the definition is here, student. Have a close look of parallel line definition, perpendicular line, line segment, radius of a circle, square. Okay, if I generally will talk you about the parallel lines, what are the parallel lines? They are never going to meet each other, okay, from this end also and from this end also, okay, and they'll be having a particular distance which were between a certain distance between these two parallel lines, and that will be constant throughout the parallel lines. Okay, so they are said to be parallel when they are not intersecting. Okay, because if we are drawing two lines and the distance between these two lines is always constant, so there is no increasing and decreasing thing. Okay, that means the distance will be constant, and the distance will be constant throughout the lines. That means they are never going to intersect each other. That does mean that they will not intersect. Second thing, they are coplanar, they are in the same plane. This is about what? This is about parallel line. Now about the perpendicular line. Perpendicular line, what is perpendicular line? If one line is perpendicular to the another one, that they are making a 90-degree angle to each other. Okay, so first thing, they lie in the same plane. They lie in the same plane, first thing. And the second important thing is they intersect to form a right angle. Okay, they intersect like this, they intersect each other at the right angle. Okay, so this is the definition of perpendicular lines. And then the third one, the line segment. What is the line segment? Okay, so the line segment is a part of line by making 2 points. The line is what which is going in indefinite in both the directions, from both the ends. But if we restrict these two ends, let's suppose P and Q, let's suppose A and B, anything. So then that will be converted into a line segment. From a line we can just add these and these ends and make it a line segment. Okay, so the distance, the line segment is a part of the line by making 2 points. If this is a line, so I'll be having 2 points here, this point A and this point B. Is it visible to you? Okay, so this is point A and this is point B. So that segment will be what? That segment of line is what? Actually the line segment. So done with the line segment too. Now the radius of circle. What is the radius circle? There is always a certain distance. This is this will be very clear to you guys when you will be studying the chapter circle. Okay, but now for this one, if you're having a particular distance from the center, you will be taking any point on the circle and you'll be having the distance of these 2 points. One is the center point and the another one is anything on the periphery or the circumference of the circle. Okay, so the distance from the center to a point on the circle is called the radius of the circle. Likewise, if this is a circle, okay, this is the center, any point on the circle, take this, okay, and meet these 2 points, the center and any other point, then that will be the what? Radius of the circle. So the radius of the circle is done. Then the square. What is square? Square is having basically 4 sides. 4 sides, that means it's a quadrilateral. Okay, a polygon is having 4 sides is what? Quadrilateral. In quadrilateral specifically what it's having? It's 4 angle all equals to 90 degree, first thing. Then the second thing, all the sides of this quadrilateral which are at 90 degree to each other are also equal to each other. Okay, so 2 things are there. A square, a quadrilateral in which 4 angles are right angles and 4 sides are equal. So if I'm having this quadrilateral here, first thing there will be right angle, the 4 angles will be right angle. The second thing is all will be equal, all sides will be equal to one another. Is it clear to you, students? Okay, let's move. Now, consider 2 postulates given below. Given any 2 distinct point A, B, there exists a third point C which is in between A and B. Okay, what's given? That consider any distinct 2 points A, B. Okay, there exists a third point C which in the between AB. So if this is AB, there is a point here C between A and B. Okay. Second, there exist at least 3 points that are not on the same line. Okay. So given any 2 distinct point AB, there exists a third point C which is in between A and B. But the second thing, there exist at least 3 points that are they are not on the same line. So here the contradiction is these 3 points are not on the same line. That means we are having something like here. Okay. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow from Euclid's postulate? Explain. So first thing, these postulates contain any undefined terms? Okay. We are having here a point. Point is undefined, right? Okay. So first thing is point is undefined. So here is the answer. There are several undefined terms. Okay. Basically there will be line also. So line is also undefined. Okay. So there are several undefined terms which the student should list. They are consistent because they deal with 2 different situations. 2 different situations are what? First situation is given the first point, second given in second one. Okay. The first, same here, that 2 points AB which is there is a point C lying on the line in between them. Okay. So there exists a third point on any given district, 2 points. Okay. So C exists here only, right? Then says that given A and B, you can take C not lying on the same line. Okay, A and B. So in the first one, it's saying that it's between the line, and the second one it's saying you cannot take C in between the line AB. So they are contradicting. Okay. So these postulates do not follow from Euclid's postulates. However, they follow from axiom 5.1. Okay. Is it clear to you? Now, the fourth one, if a point C lies between two points A and B such that AC equals to BC, then prove that AC equals to half AB. Explain by drawing the figure. So, okay, first we have to draw the figure. Let's draw the figure first. If a point C lies between two points A and B, so we are having a point A here and we are having a point B here. So, we are having AB, this line AB first, okay. Such that AC equals to BC. So, there is some point C here and now here AC is equals to BC. Then prove that AC equals to half AB. How can we prove that? Okay. Given AC equals to BC. Okay, I can add both the sides AC. Okay. This implies that AC plus AC is equals to BC plus AC. Okay. Now, AC plus AC is equals to 2AC and BC plus AC. Now, what you are going to have here? AB here. Okay. So, BC plus AC. This is AC and this is BC. So, AC plus BC will be equals to what? AB. Because these part will coincide each other. Okay. These part AC and CB together will coincide the AB. So, this is equals to AB. So, this will give that AC equals to what? Half of AB, and this is what you have to prove. Proved? Okay. In question number 4, point C is called midpoint of the line segment AB. Prove that every line segment has one and only one midpoint. Okay. So, we were having in the previous session, we will be having a line AB and we were having a point C as the midpoint. Let us assume that there is some another point D here, which is also the midpoint. Okay. Now, if this is the midpoint, C is the midpoint, that means AC equals to CB. If C is midpoint, that does mean AC equals to CB. Now, if D is midpoint, this implies that AD is equals to DB. AD equals to DB. Okay. In the first case, AC equals to CB. The second case, AD equals to DB. Okay. So, if AD equals to DB and AC equals to CB, we can do one thing. AC, okay. So, we can do one thing, that we can subtract second from the 1 by 1 minus 2. That will give us AC minus AD. Okay. AC minus AD will be equals to CB minus DB. If you look to AC minus AD, AC minus AD will be minus CD and CB minus DB will be equals to CD. That means 2CD is equals to 0 and this implies that CD equals to 0, isn't it? If CD equals to 0, if CD is equals to 0, what does that mean? That means that C and D coincide. And C and D coincide each other, that means they are the same point. So basically there must be only only one midpoint of a line. Okay, so this is about this. Next, in figure, if AC equals to BD, then prove that AB equals to CD. Okay. Given, what is given to us, guys? AC equals to BD and AB equals to CD. AC equals to BD, these are the points here, okay. So AC equals to BD and AB equals to CD. Okay, we have to prove that AB equals to, okay, this we have to prove. This is not given, this we have to prove. Okay, now AC is equals to BD. Okay, if we talk about this line, here AC is equals to what? AB plus BC. Okay, AB plus BC. Also, we know that BD is equals to BC plus CD. Now, AC is equals to BD. This is 1 and this is 2. So, we can equate AC and BD. So, by AC equals to BC, or by, we can say that equating 1 and 2, by equating 1 and 2, we can say that AB plus BC is equals to BC plus CD. Okay, so that will cancel out and then we'll be having AB is equals to CD. AB is equals to CD, and that we have to prove. So, hence prove. Okay, let's clear it up also. What is next? Why is the axiom 5 in the list of Euclid's axiom considered universal truth? So, we are going to do this particular question in our next session. For today, it's quite fine. Revise these postulates and based questions and axioms thoroughly, so you can remember which axiom number was which, okay, and you can directly use them in your solution, in your proofs. Okay, students, take good care of yourself, stay healthy, wealthy and wise. Bye-bye.